She has joined. Let me check. Let me check Professor Richa is there. So Wasim Ahmad, I am, I request you, you can, close your video. Wasim Ahmad. Just give me 1 minute. I am just, reaching around phone. Dr. Richa is with us. I am unmuting her. Just one. We need to wait 1 minute because our moderator will be joining us in a short. So I request to all the participants, if you are in a position, only then open the camera. Somebody are, sleeping and all, so it looks very bad in the recording then. So it takes a lot of, energy then to, so edit those videos. And it is not, good. So let me check the Richa is there or not. Yes, 1 minute more. Sorry for the inconvenience. Yeah.
Yes, I'm in. Hello, Dr. Fidos.
Yes, I am unable to, find you in,
Richa Banerjee.
participant. Yes, I have.
Okay.
Just
Okay,
one
so
minute. Yes, you can open your camera and
it's
start
open.
the session.
My
Yes, you
cam
can
is
start.
also on.
Yes,
My
yes, you are, ready to start. Please go ahead. You can start now, please.
okay. So very good evening to all of you. Because of some issues, Dr. Banerjee could not join as moderator, so I'm taking over his responsibility. We have session with Miss Meenakshi Kumari. She is assistant professor at Pondicherry University, Bangalore. She is driven by desire for impactful research, and she is too much into research. She is vibrant individual having teaching, learning, and research mindset. She aspired to be actively participate in academic field at different ways, particularly in economics. So I welcome her to take over the session. And before session starts, I want to request to all of you to keep your mic on mute mode so that no disturbance will be created. And you can post your queries in chat box. Whatever queries you have, we can ask to the resource person. So handing over the session to Miss Meenakshi Kumari. Is she there in session?
Hello. Yes, Dr. Meenakshi, can you unmute yourself? Yeah. Am I audible to you?
Sir, you are audible, very much audible. Good evening, everyone.
So, Miss Meenakshi, the session is handed over to you. You can proceed with the session, and we will be delighted to hear you.
Thank you so much. Good evening, everyone. I am delighted to welcome you to today's sessions on advanced research methodologies. My name is Dr. Meenakshi, and I am an assistant professor in the School of Commerce and Economics at Presidency University, Bangalore. It is a pleasure to serve as your resource person for this important and exciting topic. Today, we'll explore the linear probability model, Logit model, Probit model, and confirmatory factor analysis. These methods are crucial for researchers who aims to analyze binary outcomes and latent variables effectively. Understanding and applying these models can significantly enhance the quality and depth of your research. This session will cover the following: the linear probability model, understanding its basics, applications, and limitations, Logit model, diving into logistic regression, Probit model, exploring Probit regression and comparing it with the Logit model, confirmatory factor analysis, learning the steps involved and how it differs from exploratory factor research analysis. We'll combine theoretical explanation with practical examples to ensure a well-rounded understanding. There will be opportunities for questions and discussions throughout. So please feel free to engage actively. So we'll start with the LPM, the key features of LPM, examples of LPM in actions, interpreting LPM coefficients, limitations of LPM, assessing statistical significance and STATA implementation of LPM. So let's start with demystifying the linear probability model. I hope I'm audible to all of you. Am I?
Yes,
Yes,
you
yes,
are,
you are
please.
audible.
Yes, ma'am, you're audible.
Thank you so much. So the LPM is a type of regression model specifically used for binary outcome variables, where the results can only be 0 or 1. It is commonly applied in scenarios such as predicting whether a student will pass or fail in an exam, or if a customer will buy or not a product, the LPM assumes a linear relationship between the independent variables and the dependent variables, probability of the outcomes that we can say. This model is straightforward to calculate and interpret, making it a useful tool for preliminary research analysis and easy to understand result in binary classification problems. In this example, we are using the linear probability model to predict exam outcomes. Okay, we start by defining our variables. The dependent variable here is y, that is a binary variable. For passing, we are coded the variables for passing 1 and 0 for failing, or can say otherwise. The independent variable here is x, that is number of hours studied during exam time. And second, our LPM equations here it is, that is showing that that shows how we predict the probability of passing based on hours studied. Okay. After running the regression, we've got the coefficients beta 0 value as 0.2 and beta 1 value as 0.05. So now the next task we have that we can interpret the results. So without any studying, that suppose we've got nothing, no value, zero studies. Then without any studying, 0 hours can say, there is a 20% chance of passing in the exam. Okay. And if for each additional hours, suppose we got beta 1 value 0.05. So for each additional hours of studying, the probability of passing increases by, can say 5%. So this is the beauty of linear probability model. We can predict the probability of passing or failing in the exam. Here we have several examples of binary variable and how we can use linear probability model to take it for further study. So suppose we have one topic, a loan application is successful or not successful. So dummy dependent variable here will be loan application, and the description or definition of this loan application is 1 if the loan is approved, 0 if not. Second examples we have is labor force participation. In labor force, that is demi-dependent variable. 1 if we say that in labor force and 0 out of the labor force. Choice of occupation, if this is a topic. If a person is academician, 1, 0 otherwise. Which demography is more likely to vote in favor of a new legislation if this is the topic? Person voted, dummy dependent variable, and descriptions would be y is equal to 1 if a person is voted yes, 0 otherwise. Which factor determines baby birth weight? Baby low birth weight would be dummy dependent variable. Y is equal to 1 if a baby is born with low birth, 0 otherwise. Whether a customer is ready to buy a car purchase, that is dummy dependent variable. Y is equal to 1 if a new car is bought and 0 otherwise. These are the few examples that you can go through. Okay, if a country receives foreign aid or not, foreign aid would be dependent variable, dummy dependent variable, and 1 if received the foreign aid and 0 otherwise. So now how we can interpret the LPM coefficients. So a positive coefficient indicates that as the independent variable increases, the probability of the event occurring also increases. For example, if the coefficients for study hour is 0.05, it means that each additional hours increases. If additional hour of study increases, the probability of passing in the exam will also increase by 5%. Okay. So, and if we see the negative coefficient means that if as an independent variable, we have the social media uses, right? So negative coefficients means that as the independent variable increases, the probability of the event occurring decreases. For instance, if the coefficient for social media uses is, suppose here is minus 0.03, that is 3%, each additional hour on social media decreases the probability of passing in the exam by 3%. Okay. So now the third thing, that is near zero coefficient, a coefficient close to 0 suggests that the independent variable has a minimal effect on the probability of the event occurring. Okay. For example, if the coefficient for hours studied is 0.01, okay, each additional hour of study increases the probability of passing the exam by only 1%. So that is just not giving any influence or impact on passing the exam. Okay. So A natural starting point in the linear regression model is the simple linear regression with a single regressor, which establishes a basic linear relationship, okay, between the response and a solitary predictor variables, serving as a foundation of more complex models. So here, the explanation of linear probability model. Linear probability model takes OLS for estimation. So y is equal to a plus beta x plus u. This is the initial model. We can recall the assumptions of CLRM, that is expectation of ui given xi is equal to 0. So if we see expectation of yi given xi is equal to expectation of saying this value, that expectation of a plus beta 1 x plus u given xi should be equal to a plus alpha plus beta xi. Okay. So when y is a binary variable, that is y is taking 1 for success or 0 for failure, in that case, expectation of y will be 1 into probability of y is equal to 1 plus 0 into probability of y is equal to 0. In that case, if we are multiplying 0 into probability of y is equal to 0, this side will get 0. So we'll be ending up with probability of y is equal to 0. So the end result is expectation of y given x is equal to probability of y is equal to 1, condition 2x, conditional x, is the probability that y takes on the value of 1, that is 6. Okay. So we'll take one example in the wake of, this is the example of 2008 crisis, financial crisis. Many banks in Boston Fed were forced to take stringent measures in granting mortgage loans. This caused many credit worthy applicants to be denied loans. In a study to determine the likelihood that a loan application is successful, 30 mortgage applications were analyzed. The response variable here is y is equal to 1 if loan is denied, 0 otherwise. So dependent variable y is equal to 1 if loan is denied, 0 otherwise. Loan approval is believed to depend on the size of down payment and income to loan ratio. That is income, whatever income is there, and what will be the loan. Okay. According to the following linear model specify that is y is equal to alpha plus beta 1 x1 plus beta 2 x2 plus epsilon. Here x1 is nothing but down payment and income to loan ratio is x2. So we made the regression model. Now we'll go to STATA window to take one example. Okay.
Are you facing any issue?
Just a sec, sir. Yeah. So my screen is visible to you, sir?
Yes,
Yes,
screen
okay.
is visible, but I would, request you, if you show the all training that how you have uploaded the file in this data, because in the post session,
Sure.
to some
Sure.
extent we
Okay.
have missed that part. You show the participants how you are uploading the file manually on you,
Yeah.
and then how you
Sir.
are processing. Thank you.
Okay. Sure, sir. So we will take one data sets. I have already shared the data sets with you. Take the Excel data sets. First of all, I have already done some run some things. So I'm clearing all the clear all means whatever I have done till now will get cleared out. Now we'll type edit in command window. When I'm typing edit in command window, one file will get appear here. So now open your Excel file that I have shared with you. Copy the DP, IL and deny. Okay, I'll select again. DP, IL and deny. Alt, drop down window. All get selected. Copy and go to STATA window. STATA. Okay. Now here, go to edit. In the first row and first column, you can paste it. When you are pasting, you can see here, it will be asking for variable names as the first row. Click on variable names. Your data will be pasted here. Okay. So here you can see here that DP is a down payment. IL, income to loan ratio, deny 1 if the loan is denied, 0 if the loan is accepted. Okay. So we have these variables. Now we'll go to STATA window. First of all, what we'll do, we'll see what is there. So describe If we put type describe, click OK, we can see here we have 30 observations, 3 variants, and size is 270. Now, we'll see the scatteredness of the data sets. Scatter. We'll take deny as the denied variable, DP down payment, and we'll click on OK. We can see here one graph will appear on the screen. It's showing that on 0 we have some responses, on 1 we have some responses, and the rest of the area is blank. Okay. This is showing that outcome is in the form of 0 and 1, that is binary in the nature. So we've seen the scatterness of loan denied and down payment. Now we'll see the scatter. If you have STATA, you can work on with me. And I click on OK. You will see the same condition. Okay. Outcomes are on either on 0 or on 1. We'll see just to make you comfortable. Loan denied. Also, we've run all the TP denial. Yeah. Now, what we'll do next, we'll run the regression, or we can summarize the data also. Summarize. You can write whole, or you can write in half. Summarize all the variables, dependent variables, independent variables, and independent variables, all the values. Now, summarizing the data will give you the details of mean, standard deviation, minimum, maximum of the data sets. Now, we've got all the information about the data sets, that how many observations are there, what is the minimum value, what is the maximum value, what is the standard deviations, how many observations are there in denial and down payment and income to loan ratio. Now we'll run the regressions. So LPM follows OLS method. So we'll simply run the regressions. We have the command regress, reg, and first of all, we'll keep the dependent variable. Loan denied is a dependent variable. DP, down payment, is independent variable. Income to loan ratio is another independent variable. I have taken 2 independent variables to run the regression. Press enter. You will get this result. Okay. Here, you've seen this results. I have put the same result on the. Just a sec. Again, I need to. So here we have the result that we just we have run today. And now, so now what is here?
So before proceeding, I am having one question.
So
we have run this regression model.
Yes, sir.
Okay. So, but our dependent is dichotomous. It is having 2
Dichotomous.
categories.
Yes.
So do we need to use the simple regression model, or we should use here Logit or something?
No, sir. In LPM, we follow OLS method only.
Okay, we are using LPM model.
LPM,
So
yes, sir. LPM.
For LPM, we have to simply use regress. Rig.
Yes, sir. OLS,
So,
ordinary least square method we will be using for LPM.
So my question was that how software will know that we are using LPM model?
Sir, there are so many limitations we have. Let me complete this LPM. I'll let you know that there are limitations. That's why we are moving on to Logit and Probit.
Okay. Thank you.
Yeah, no problem, sir. So now here when we run the regressions, we will be having the output right here. We can see that a regression model is statistically significant at 0.0001. Okay. And about 5.5058, that is of the variation and the loan approval process is accounted by the regression on down payment and income to loan ratio. Now we can also see that likelihood that a loan would be approved is a positive function of down payment and income to loan ratio. Okay, because these coefficients are positive, specifically beta 1, or can say this down payment is 0.01880, meaning that 1% increase in down payment okay, would increase the loan approval probability by about 0.0188. In other words, there is a 1.88% chance that the loan will be approved. Okay, for 1% increase in DP down payment. Okay, similarly, beta 2, that is income to loan ratio. If there is that a 1% increase in beta 2 value, that is 0.0258, right? Suggesting that a 1% increase in customers' income to loan ratio, right? So income to loan ratio will increase the loan approval probability of 0.0258, right? So that there is a 2.58% chance that a loan being approved worth at 1% increase in income to loan ratio. And these are all statistically significant, 0.000, you can say at 5%, okay? So with that, we can actually go ahead and estimate the regression equations in the way I have summarized here. So this is our p hat that we can probability, or p hat that is deny hat, right? Which is the same thing as y hat, the estimated regression equations. We are putting the values of beta coefficients, that is 0.8 minus 0.8680 is the value of beta 0, plus 0.0188 DPI plus 0.0258 ILI. So what is the predicted probability for income to loan ratio if it is equal to 0.3? So in this slide, we can see that beta 1 value is positive. So we can say that 1% increase in down payment increases loan approval probability by about 1.88%, right? The same thing with beta 2. So estimated regression equations we've just seen in the last slide. For example, suppose down payment is equal to 20%. Income is $60,000. Loan is $20,000. Then income to loan ratio will be $60,000 divided by $20,000. That is 30%, right? So predicted loan approval probability will be, if you put the values here, first case DP is 20% and IL is 30%. So we are putting the values, we are getting the total value 0.282. Note that if DP increases by 30% from 20% to 30%, 10% hike, when IL remains at 30%, so what will happen? Probability will increase from 0.282 to 0.47. Okay, probability of denial of loan will increase. So as DP increases by 10%, predicted probability of loan approval increases by 0.188%. Okay. So now I have, this is the quick summary of the multiple regression model, where the likelihood of a loan being approved is a function of down payment and income to loan ratio. Okay. So here, y would take the value of 1 if the lending institutions grants a loan, 0 otherwise. So for the first customer, loan was granted and he or she, right, has a down payment of 16.35% and income to loan ratio is 49.94%. Another customer, if we see at the down, 0, whose loan was not approved, whose loan was approved, that is, whose DP was 17.85 and 26.86%. Okay. Now, this slide is showing the limitations of LPM, right? The slide shows the relationship between mortgage denial and the ratio of debt payment to income ratio, okay? X-axis represents the ratio of income to loan ratio, just taking one example, and the y-axis is denial, okay? Example, here, if annual earnings are 1 lakh, suppose, and debt and income to loan ratio is 30,000, right? Then income to loan ratio will be 0.3, right? On y-axis, we have denial variable, binary variable 0 to 1, right? That's why we have 2 points, 0 and 1. Whatever outcome we are getting on the responses, actual values is all are on 0, either on 0 or on 1, okay? A binary variable indicating mortgage status 0 for approval and 1 for denial. Observations from the graph is that points at 1 on the y-axis is that mortgage application denied, point as 0 on the y-axis, mortgage applications approved. Okay. Interpretation, if we have to see, lower PI ratio, lower income to loan ratio generally increases the probability of mortgage approval. Okay. And higher PI ratio or income to loan ratio generally increases the likelihood of mortgage
So
denial.
if you are comfortable, can we take one question? If there is somebody, yeah. Let's
So,
make it
if,
interactive. Let us make it
yes, sure,
interactive session.
sure, sir, sure.
Mohammed
So,
Ali,
but
can you?
I have one thing to say, because I have to complete LPM, Logit, Probit, and CFA using STATA. It will take more than 2 hours to complete. If the session goes like interactive, well, if I am okay with 2 hours or two and a
Only
half
one
hours.
question. Only one question we will take here.
Yes, sure,
So
sure,
after that, we are going to take by the end. Then you know,
sure.
pick up the speed. Mohammed
Yeah.
Ali, can you ask your question quickly?
Thank you
Yeah.
so much. I'm sorry for the interruption. I just
No.
clarification question in the equations. Your deny variable was actually approval variable, right? Because approval equal to 1. Here in the graph, it is denial equal to 1. So
No,
are
sir.
they
Denial
different
is
variables?
No, sir. Denial is equal to 1. Approval is equal to 0. And from the beginning, I am talking like this only.
Ma'am, if you go to the previous slide,
Sure,
it
sure, sir.
says if the loan is no the next one
So here,
the
1 if loan is denied, 0 otherwise. Can you see
the
here, sir, the first slide?
Mhm.
In the slide, sir?
Yes. So if you go to the slide just before the this weakness of LPM thing.
Mohammed
Yes,
Ali
sir.
Sahab,
Sir?
No,
May-
one later.
yeah,
Here,
one
if
is
you say
non-approved.
y equal no.
No, previous. There is some error, so can hard,
Okay,
hard.
thank you.
Yes.
So
Oh,
here
sir,
is
this
y
is
equal to
a
1 is approved.
typo error, sir. So sorry. This is a typo
Yeah.
error. This is a typo error. So sorry.
So is there any more? No. So you can proceed and we can take questions. We
No
try to
problem.
cover as much as you want. So I think where participants will be,
Sure.
they will be happy to, get more.
Okay, sir. Where were you? Where were we? Here only. So here if we talk about interpretations, so lower income to loan ratio generally increases the probability of mortgage approval. Higher loan income ratio generally increases the likelihood of mortgage denial. Suppose hmm. So like suppose paying 60% of income towards existing debt lowers mortgage approval probability due to limited remaining income for basic needs and new debt. Okay. So LPM, this is the blue line here representing the LPM fit. It shows a general trend, but fails to capture extreme data points accurately, right? Actual data are on 0 and 1, and this is LPM because it follows OLS, so it will get a straight line curve, right? LPM may predict unrealistic probabilities outside the 0 and 1 range. For example, if an income loan ratio is 0.4, may have predicted denial value that doesn't match observed values. Okay. If we say the limitation of LPM, it is a poor fit for binary outcomes, especially at data extremes. Large deviations between the fitted lines and actual data suggests the need for a better model, such as logistic regressions. LPM, this is the LPM linear fits doesn't adequately describe the relationship between income to loan ratio and mortgage denial. Okay. What would be the problem with NPM? There are a couple of problems associated with LPM. Since it is based on OLS approach, but the problem includes one, the models can't produce predicted probabilities that are either greater than 1 or less than 0. And in that case, it would have no economic interpretation. Since probabilities should be bounded with the closed interval of 0 and 1. For example, we will find that the P value the probability would take on negative values also, okay? If the customer has no down payments, however, with income to loan ratio of 30%, okay? So the outcome would be minus 0.932, okay? Makes no sense as well, okay? The outcome probability is equal to 1.0372 in the coming things I will show you is more than 1. In this case, that is 1.07372 with 60% down payment and income to loan ratio of 30% will not work. Here, I change the down payment by 10% to 0%. Okay, leaving the income to loan ratio as it is, 30% to remain, okay. And I recalculated P hat. Okay. As you can see, quite surely as down payment increases from 0 to 10, 20, 30 to 90%. Okay. Increases, the probability of success, as it were, also increases. Okay. But in some cases, probability is negative, and in fewer other cases, probability is more than 1. In this case, 60, 70, 80, and 90, probability is 1 point, 1 point, 1 point, and so on. And the first case probability is minus 0.094. So these are the statistical problem. This estimation process is a little bit wanting in terms of its ability to help us predict outcomes. Second problem is that the changes in probability from one level to the next level are the same across the board, 0.1883. Okay. So for example, if a customer initially says, I'm going to put down 10%, okay, and then subsequently says that I'm going to kick it up to 20%. Surely we would expect the probabilities to increase as it has. And in this case, it goes up by 0.1883. But that's fine. But think about this. If another customer says that I'm going to put down 70% and then subsequently changes his or her mind to 80%, again, sure, would expect the likelihood of the loan approval to increase, but for goodness sake, so as you can see here, it really shouldn't be at the same rates of increase as we would expect. Customers moving from 10 to 20% and so on. Now with 70% down payment, you are already a very good prospects. So if you change your mind to 80%, how wonderful customer you will be. Why that has increased really is not saying anything much more than what you already were, a very good individual who can put down 70% and so on. So I guess the point to note here is that we would expect the increase in probability nuts to be, can say, as dramatic from 70 to 80% as would be the case. Okay. Limitation, if we have to see the limitation of LPM, we found some serious limitation in the use of LPM, the most serious of which is that we could wind up with estimated Y values that are greater than 1, even negative also. Such outcomes simply do not make sense. The probability of success cannot be more than 1 or being negative. So we are interested in what makes changes from 0 to 1. Probability means 0 to 1. The range of probability is between 0 to 1. Or if what increases the odds of loan approval. What increases the probability of success? So in developing the logistic function, the two conditions must be met are, first condition, probability of y is equal to 1 given x to be an increasing function on x for beta 1 that is greater than 0, and second condition would be the probability value of y is equal to 1 given x should be in the range between 0 to 1 for all x. This requires using non-linear functional form for the probability. Okay. So we have another model that is logistic regression model. We will discuss about the overview, assumptions, statistical significance, effect size, and practical significance of logistic regressions. So logistic regression is a powerful tool for social scientists because it allows us to analyze data with binary outcomes. Unlike linear regression, which is used for continuous dependent variables, logistic regression can handle the fact that our outcome variable can only take on two values, right? The sigmoid function ensures that the predicted probabilities always fall between 0 and 1, which makes it a good choice for modeling probabilities. We have some examples. Just as we know that social science research often deals with questions that have binary outcomes. For instance, we might be interested in understanding what factors influence people's decisions to vote or not vote. Okay. Logistic regression is a perfect tool for this type of analysis. It allows us to examine the relationship between various independent variables, such as income, education level, political ideology, and the probabilities of someone's voting. By using logistic regression, we can not only determine which factors are statistically significant, but also assess the strength and direction of their effect. Let's consider an example of how logistic regression can be used in practice. Suppose we want to predict voter turnout in an election. We can collect data on a sample of voters, including their income level, age, education level, and political affiliations. By running a logistic regression analysis, we can estimate the model coefficients. If the coefficients for income level is positive, it suggests that people with higher income are more likely to vote. Conversely, if negative coefficient for age might indicates that younger people are less likely to participate in election. This analysis can help us to understand the factors that influence voters' turnout and develop strategies to increase participation. Let's break down the logistic probability function in a way that's easier to understand. Imagine you are trying to predict something that can only have two outcomes, right? Like whether it will rain today or not. The logistic regression functions help us to do what by giving us a probability between 0 and 1, okay? Where 0 means no chance of rain, 1 means it will definitely rain, right? Now this function uses a special math expression, right? That always stays positive. Here we will be seeing that p is equal to exponential of beta 0 plus beta 1x to the power exponential of beta 0 plus beta 1x. It will always be positive, right? No matter what numbers you put into it, that's important because we can't have negative probabilities, right? Also, this expression will never give us probability greater than 1, which is perfect because our probabilities need to stay between 0 and 1. But why do we add the number 1 here in the second case? That is, must always be less than 1. Why are we adding 1 here? But, well, it's like a balancing act, okay? If we have a really big number in our equations, adding just 1 won't change much. It's like adding a drop of water in the ocean. So our probability will be very close to 1, okay? Which is our maximum. On the flip side, if our number is super tiny, adding 1 makes a big difference. Like it's like adding a whole bucket of water to a tiny puddle. This will give us a probability close to 0, which is our minimum. Okay. So by using this logistic function with its special add-one trick, we make sure our predicted probabilities make sense. They are always between 0, that is no chance, and 1, certain chance, just like we need them to be. Now let's build up the logistic regression model. We start with the odds ratio because in logistic regression, we take log odd ratio. In the left-hand side of this equation, you can see that log of p over 1 minus p means success, 1 minus p means failure, okay, is equal to beta 0 plus beta 1x. Here, the term log of p over 1 minus p called the odd ratio. So taking the natural logarithm of the odd ratio gives us the left-hand side equation, okay? And right-hand side, we can see that beta 0 plus beta 1x, that is a linear line, okay? Because even though the probability p is not a linear function of x, its transformation, taking log, will make it a linear functions. It is, okay? Our model is what is implemented as logistic regression. Now, the derivation of the log odd ratio from logic function is right here. How we are reaching from probability of p is equal to e to the power beta 0 plus beta 1x, so divided by e to the power beta 0 plus beta x plus 1. And after along derivation, we are reaching to log of p over 1 minus p is equal to beta 0 plus beta 1x. Logistic regression is a powerful statistical tool used in social sciences and various fields to model the relationship between one or more independent variables and a binary dependent variables. Okay? In this single slide, we will explore the concept of maximum likelihood estimation. Okay, the primary method of estimating the coefficient of in a logistic regression model. The slide incorporates a sigmoid function visualization to represent the transformation of the linear combination of predictors into probabilities. Okay, the bullet points highlights the key steps in MLE and how we interpret the estimated coefficients in logistic regressions. While we focus on odd-on ratio, exponentiating the coefficient provides the odds ratio a more intuitive value for understanding the impact of variables on the probability of the positive outcomes. How we interpret the logistic regression results. So goodness of fit is helpful metric to assess the logistic regression models overall performance in predicting the correct category. Okay, while the percentage of correct predictions provides a basic idea of accuracy, it's important to consider the chosen probability threshold for classification. Using a higher threshold can increase the model's precision for identifying positive outcomes, especially in cases where the negative outcomes category is more frequent. So here, 2 of the cases are correct predictions, 2 are wrong. If predicted probability is greater than 0.05, activity y is equal to 1 will be true. And if the predicted probability y hat is equal to 0, then activity y is equal to 0 would be true. Rest will be false. Okay. But it's safer to use a high cutoff, say greater than 0.70 to verify the effectiveness of the predicted model. So this slide emphasizes the beta coefficients reflects the influence of each independent variables on the model's predictions of the positive outcomes. Okay. Considering the log odd ratio, beta 1 specifically represents the effect of the first independent variable x1. The bullet points highlights the 2 main interpretation of beta 1, okay, based on its sign. So it's crucial to remember that beta 1 itself doesn't directly tell us about probability changes, but rather the change in log odds. Okay. So positive beta 1 indicates that 1 unit increase in x1 leads to an increase in the log odds to the positive outcomes, and negative b1 suggests that a 1 in unit increase in x1 leads to a decrease in the log odds of the positive outcomes. This is the comparison we can say between Logit and Probit, Logit and LPM model. We've seen how estimated probability from Logit model are bounded between 0 and 1. Unlike the LPM, which sometimes can take the probability value exceeding 1 or below 0, right? And also unlike the LPM, the Logit model probability do not necessarily changes by the same magnitude for all values of x, as you can see right now. Here is not quite as much as here in the middle. Here, you can see that in the middle, and in my view, outcomes from Logit model offers us more realistic picture of how our behavioral responses changes. We are getting straight line through LPM, and we are getting a sigmoid curve using Logit model. In linear probability model, first of all, we'll discuss about LPM. And on x-axis, we have down payment, and on y-axis, we have denial variable, right? X represents the predicted probabilities of the positive outcomes, right? So this straight line will be plotted on the graph representing the linear relationship between the independent variable and the dependent predicted probability, right? The slope line indicates the change in predicted probability for a 1 unit increase in the down payment ratio. On the other hand, logistic regression, we are getting S-shaped curve, sigmoid S-shaped curve will be plotted on the graph. This curve depicts the non-linear relationship between the independent variable and the dependent variable. And after transformation using the logistic function, we can get the results. So key points if we see in LPM graph shows a constant change in predicted probabilities for each unit increase in independent variable. Whereas in Logit model, graph shows a gradual increase in predicted probabilities as the independent variable increases, right? Approaching to 0 at a very low values and at very high values, right? This reflects a more realistic scenario, whether the probability of the positive outcomes doesn't simply jump from 0 to 1, but gradually increases or decreases with changes in the independent variable. By looking at these separate graphs, you can understand the different approaches LPM and the Logit model take in predicting probabilities for binary outcomes. Okay? The LPM offers a simple interpretation but can be unrealistic for modeling probabilities. Okay? The Logit model addresses this limitation with its S-shaped, sigmoid S-shaped curve, but requires a slightly more complex interpretation of the coefficients. Let's go back to the STATA window. Stop sharing. And then share again. Yeah.
You can also share the entire screen, and then you do not have to off
Yes, sir.
while moving here and there.
Sure, sir. I can share this entire screen, right, sir? Shall I do that now?
Yes, so that you will not get this problem of closing one window and another.
Sure, sir. Is my screen visible, sir?
Yes,
Thank you,
we
sir.
are on the data window.
Okay, thank you so much, sir. So here we are on the STATA window, and we have to run the logic. Oh, क्या किया मैंने?
Yes, all is right.
Yeah,
You
now
have
it's
to
visible,
just
yes. Yes, sir. So now here we are on the STATA window. So we've already summarized the data. We are taking the same data to do the logic regression, to run the logic regression, Probit regression, and others. So we'll directly run the regression. That is, we'll put the command logit, and then we'll take the dependent variable, then independent variable, all the independent variables we've taken. Okay. Logit command will be logit deny dpil. That is logit dependent variable denial, independent variable down payment, and another independent variable income to loan ratio. We'll click on OK, enter OK. We'll get the results. Okay. Here we have get this results: log likelihood ratio, number of observations, LR chi-square, probability of chi-square, pseudo R-square value, and other coefficients of DPIL and constants. Okay. Standard errors, V value, probability of Z, 95% confidence intervals. Let's go back to the main slide. So here the same outcome I have copied and pasted over here. This outcome shows the logistic regression of mortgage denial on down payment and income to loan ratio, right? The coefficient of DP, that is down payment, is 0.1348, right? Which means that for every 1 unit increase in down payment, the log odds of having loan denial increases by 0.1348, having other variables constant, holding other variables constant. This implies that higher down payment is associated with higher probability of having high loan denial. Okay. The standard errors of the coefficients are the estimated standard deviations of the sampling distribution. They measure the precision of the estimates. Smaller standard errors, as Professor Naik said, means more precise estimates. The Z statistics are the ratios of the coefficients to the standard errors. They measure the significance of the coefficients. Larger Z statistics in absolute value means more significant coefficients. Okay. P-value, you can see here, P-value are the probabilities of obtaining the coefficients or more extreme values by chance if null hypothesis of no effect is true. Okay. They measure the evidence against the null hypothesis. Smaller p-values means more evidence against the null hypothesis. The 95% confidence intervals are the ranges of values that contains the true coefficients with 95% probability. They measure the uncertainty of the estimates. Narrower confidence intervals means less uncertainty. Now, here, LR chi-square statistics is a likelihood ratio, chi-square test of the overall fit of the model. It compares the log likelihood of the model with the log likelihood of the null model. It measures how much the model improves the fit compared to the null model. Larger LR chi-squared statistics means better fit, right? Here we have 19.22. It's not a good fit. The probability prob greater than chi-square, we consider it as p-value of the LR chi-square test. It measures the evidence against the null hypothesis that the model doesn't fit better than the null model. Smaller p-values means more evidence against the null hypothesis. The log likelihood is the value of the log likelihood function at the estimated coefficient. It measures how well the model predicts the observed outcomes. Higher log likelihood means better predictions. The pseudo R-square, here we have 0.4681, is a measure of the proportion of variation in the outcomes that is explained by the model. It is analogous to the R-square in linear regression, and higher pseudo R-square values means more explanation. Now the task ahead of us is the transition of the result into logistic functions. Okay. So here we have the functions that log of p over 1 minus p is equal to beta 0 plus beta 1 dp plus beta 2 il. And if we are putting the coefficient values, that will be minus 9.3670 plus 1348 dp plus 0.1782 dl. Okay. Estimated probability, predicted loan approval probability will be like this, adding plus 1 in the denominator. Now, note that the estimated Logit model is the log of odd ratio. To find the estimated probability, we define the Logit function for the two independent variables and then substitute the estimated value of the coefficient as shown there. So this is the predicted loan approval probability, which can be calculated for different levels of down payment and income to loan ratio. But how we can interpret the coefficients? Okay. Here, the same model I have written on the top. Consider beta 1 is equal to 0.1348. That is a coefficient of dp. For every 1 unit increase in down payment, the log of odd ratio increases by about 0.135 unit or 0.134 only, right? 0.135 or 0.1348, whatever you can say. So for every 1 unit increase in down payment, log of odd ratio increases. That is ln p over 1 minus p. But remember that log of odd ratio, that is ln log of p over 1 minus c is the log of odd ratio, not the probability p. For this reason, we only interpret the sign and not the magnitude of the coefficient in a Logit model. So we are looking for the sign, whether it is positive or negative, and accordingly we interpret the results. To interpret an odd ratio, you can use this guideline. So if the odd ratio is greater than 1, okay, it means that the variable is associated with higher odds of the event. If the odd ratio is less than 1, it means that the variable is associated with lower odds of the event. If OR is normal, equal to 1, it means that the variable is not associated with the events at all. You can also express the OR as a percentage increase or decrease in the odds of the event, right? Now we have the third model,
Can you calculate this odd ratio also on STATA so that write the command of logistic?
Sir,
We
do not. Sir, we do not do on STATA, sir. As per my knowledge, sir, we calculate
yes,
and then we put the values on.
On STATA there is a command. If you write, instead of Logit, you can write logistic. Odd ratio should be generated.
Yeah, logistic log. You're
Yes,
right, sir.
yes. So that is, participants can learn how to calculate odd ratio. Can do the, 1-2 seconds
Okay,
on
sir.
that also.
Sir, I didn't get you. I lost you. I've lost you.
Yes, you can write on STATA as you have run simply Logit model. You can go to STATA window and
Sir?
instead of same command, you bring the same command there. Right now, logistic.
This is the difference between all these Logit and logistic.
Yes, it will now generate. Before there were coefficients, now we will get odd ratio. Isn't it?
Now here we got odd ratio. This
Yeah.
1.10 means that, and this dp only I have taken one value. Okay.
As you have explained theoretically odd ratios, so now
We'll take all the
yes,
yeah.
it can take
We'll
all.
take all the three variables. We'll take all the two independent variables. Now here both the variable odd ratio is greater than 1. So we can conclude that the log of odd ratio is higher, right? That the variable is associated with higher order of the events.
Yeah,
So
you can go with now. I'm asking now. You can go with the explanation, so we can.
okay, sir. Okay, sir.
And one
So
more query.
Sir.
If it is interesting one. For example, our dependent variable is binary 0 and 1.
Yes.
Now we have supposed ourselves that if the loan deny, our dependent variable, if the loan deny, then what is the percentage? To calculate that, how much the coefficient is with respect to 1 and how much it is with respect to 0, we can add before dependent variable I dot. So if you can, try that, then we can go to the next, model. Sorry for, disturbance. So I thought, these are two important pointers. We are having more than 100 participants. There are patients learning.
So,
So the same model which we have run poster
yes,
Logit
yes.
after selecting the dependent variable. So you try to write I dot. No.
No,
Before
no,
the dependent variable.
no. Before deny, I dot is an indicator function which
Yes,
indicates
it shows,
I dot no space. I dot no space.
yes, there is no space.
Yeah. Now all the independent variables. No.
No.
Logit I dot deny, then the two independent variables. Yeah. Okay.
It is not showing here. It can work only as a
This
independent
doesn't.
variable.
No,
Sorry?
sir.
Yes, please go ahead. Somebody.
This doesn't work with categorical variables. So we have a few
No,
aspects
it
in
can.
which
It can. It
So
can. It
all
can.
all are
You try to you just I am asking you what to do. You write rig.
so these
You
are
write
not categorical variable. You can see here. These are changed.
no. Deny is categorical variable, isn't it?
That is okay, but quoted at 0, 1.
Yes, you write reg. I'm having doubt about it. Why it is not running. Write reg. Then write dependent variable something else. Don't write this deny. Write dp. Write dp dependent variable. We are just
Sorry?
trying. Write dp
Okay.
as a dependent variable.
Okay.
Then then add I dot deny.
Okay.
Yeah, this your previous dependent variable. Deny and add.
Mhm.
It didn't work. I think you are having. Okay, let us not waste your time here now. Let us go to next. I think it will work. I don't know what it is. So let us move to every condition.
Now we have the third model, that is Probit regression model. We have seen that in NPM, we model the probability of a dependent variable taking a value 1 as a linear function of the predictors, independent variables. In the Probit model, we'll take the same. LPM has limitations. The limitations will be covered up here also in Probit model. Logit and Probit both are almost similar model, but there are some differences here. In Probit model addresses the limitation of LPM, and it is also a non-linear relationship instead of linear functions. We use here the cumulative standard normal distribution functions that we call it as Probit functions. And Probit ensures that predicted probabilities stay between 0 and 1. It accounts for heteroscedasticity. LPM accounts for homoscedasticity, and Probit accounts for heteroscedasticity. The Probit model relates the Probit inverse of the CDF, cumulative standard normal distributions of the probability of success to predicted probability. Probability of y is equal to 1 given x is equal to beta 0 plus beta 1x. All right. But here in Probit, we take cumulative standard normal distribution function. The interpretation of Probit regression model will be the same as Logit and LPM, means increasing raises the probability of success. Exponentiating the coefficient gives us the odd ratio in terms of the logit. Standard normal distribution, the Probit function ensures that our predicted probabilities follow the standard normal distribution. It satisfies the requirement of probability between 0 and 1. Here, the S-shaped curve here again are referring to as a fundamental feature of the Probit model. The Probit model is used for binary classification, as we've seen, and it predicts probability between 0 and 1. Instead of assuming a linear relationship, the Probit model uses a cumulative standard deviation functions, cumulative distribution function, okay, to map input features to probabilities. Specifically, it employs the standard normal distribution. Also, we know with the name of Gaussian distribution. So, standard normal distribution has a bell-shaped curve that we know. Its probability density function is given as function of x is equal to 1 over 2 pi into e to the power minus x square over 2. And the cumulative distribution function of the standard normal distribution gives the probability that a random variable falls below a certain value, phi of x is equal to integration range between infinity to x ft dt, right? The CDF produces an S-shaped curve which asymptotically approaches 0 on the left and 1 on the right. In the Probit model, we use the inverse of the standard normal CDF to measure linear combination of input features to probabilities. Okay. Advantages, if we see a Probit, the S-shaped curve ensures that predicted probabilities stay within the valid range of 0 to 1. It captures non-linearity, but better than a simple linear model. The model is robust and widely used in fields like epidemiology, finance, and social sciences. Imagine a bell-shaped curve like a hill called the standard normal distribution. It represents a continuous random variable with a mean of 0 and a standard deviation of 1. The curve is symmetric around the mean 0, right? The cumulative standard normal distribution, the CDF, gives the probability that a random variable from the distribution is less than or equal to a specific value. For example, suppose we got that phi value is 1.5. That represents the probability that a standard normal random variable is less than or equal to 1.5, right? We find the value using table or calculator approximately, and we got approximately 0.9332 like a value. So predicted probabilities in the Probit model, we use the CDF like I said, and given input features like we calculate Z, right? Z score. These Z scores correspond to points on the standard normal distribution, right? The CDF, we say it as those points gives us the predicted probabilities. Now the question arises why we take standard normal distribution. We can't directly use the cumulative normal distribution for predictions. Okay. Instead, we rely on the standard normal distribution because it's well understood. Tables of these Z table will provide us scores and corresponding probabilities also. Right. So phi function of Z is evaluated as Z, we call it as beta 0 plus beta 1 x value, and phi, that is integration value. Okay. So here, suppose beta 0 value we have is minus 2 and beta 1 3 x, the value we have actual value that is 0.4. So if we have to interpret, we are the predicted probability is based on the cumulative standard normal distribution. So that's why probability of y is equal to 1 given x is equal to 0.4 would be equal to, we will put the values here and we'll get the value minus 0.8, which is, we will see in the Z table, right? That what is the value of minus 0.8 that we are getting, that is the value at 0%, I mean 0 level, that is 0.2119, right? So after calculating and seeing the value on Z table, the result is approximately 0.21 or can say 21.19%, right? So interpretation would be the probability that Y takes the value 1 gives is equal to 0.4 is approximately 21.19%, right? So after finding the value, we have to see the value in the Z tables, LZ table, Z table, and accordingly we will finalize the results. So the cumulative standard normal distribution that we call as Z distribution is preferred for several reasons. One, shape. Its S-shaped curve ensures that probabilities remain within a valid boundary of 0 to 1. It avoids extreme values. It prevents negative values and values greater than 1. Increasing probabilities as Z-score increases, positive values of beta 1 probabilities increases. Easy to use, right? And widely used. In the Probit model, the linear function defines the Z-score, right? Z is equal to beta 0 plus beta 1 xi, right? The predicted probabilities are calculated using the cumulative standard normal distribution, specifically this one, right? We have this result already taken from STATA window. Okay, this output shows the results of the Probit regression of denial on down payment and income to loan ratio of HMDA datasets. The other statistics are similar to those in the Logit model, except that they are based on the Probit model with multiple predictors here also. The pseudo R-square is also the same, indicating that the model with multiple indicators, predictors, explain the same amount of variation in the outcome as the Logit model. Okay. Coefficient interpretation, if we see, the coefficients in your model, in our model is positive. Okay. As the income to loan ratio to income increases, the predicted probability changes. Higher income to loan ratio means greater financial pressure, whereas a larger proportion of income goes towards debt payment. If your monthly income to loan ratio is 0.7, you are paying 70% of your income towards debt, right? So the variable denial takes binary value 0 accepted or 1 denied. So when applying for mortgages, 0 that is accepted, 1 application are disapproved, right? But while interpreting, keep in mind that other factors may influence mortgage decisions beyond just the income to loan ratio, right? We have other things like credit score, employment history, etc. That also play a important role. The income to loan ratio or the PI ratio represents the debt payment to income ratio, right? As the ratio increases, more of our income is used to pay off existing debts. The financial pressure affects mortgage applications, of course. Let's calculate the probability of a mortgage application being denied, taking the value 1, giving a PI ratio of 0.3. Using the cumulative standard normal distribution, we find this probability to be approximately 0.097. Okay. Now, if changing the PI ratio from 0.3 to 0.4, the probability of denial given a PI ratio of 0.4 is approximately 0.159. The change is substantial from 9.7% to 15.9%, right? So when the PI ratio increases, predicted probabilities of mortgage denial rises significantly, right? 0.1 increase in the PI ratio corresponds to a 6 percentage point increase in the probability of denial. This is the interpretation of the things. Now, if we see the comparison of Logit and Probit model, Logit model assumes the logistic distribution of the error term. This results in a sigmoidal S-shaped curve. Probit assumes a normal distribution of error term, also leading to a sigmoidal curve, but derived from the cumulative distribution function CDF of the normal distribution. If we see the link function, Logit model uses a logistic regression link function. Okay, that is logit P is equal to log P over 1 minus P. Probit uses the Probit link function, which is the inverse of the normal CDF. Logit, if we see the interpretation of coefficients, in Logit model, coefficient represents the change in the log odds of the dependent variable for a 1 unit change in the predictor variable. On the other hand, Probit coefficients are interpreted as a change in the z-score of the dependent variable for a 1 unit change in the predictor variable, that is independent variable. If we have to calculate in Logit, generally computationally simpler and often preferred in practice due to direct interpretability in terms of odds. And in case of Probit model, can be more computationally intensive due to the integration involved in the normal CDF, but sometimes preferred for its theoretical properties and better handling of certain types of data. If you see the application prospects, Logit commonly used in cases where odds are a natural interpretation, example, binary outcomes in health studies. Probit model often uses in situations where the underlying latent variable is assumed to be normally distributed, like modeling threshold in psychological studies and so on. So both models are used for binary outcome variables and yield similar results in practice, but the choice between them can depend on theoretical considerations and specific application needs. Now, the fourth one, that is the confirmatory factor analysis. CFA is a statistical technique that models. This is different from LPM, Logit, Probit. This is the fourth one. It is a little bit different from all the three models that we've just discussed. CFA is a statistical technique that models unobservable, or we can say latent variables using observable indicators or measures. CFA is a specific applications within the broader structural equation modeling framework, which examines relationship between latent and observed variables. CFA assesses the internal structure of a set of observed variables and how well they represent the underlying latent construct of or factors. The theoretical constructs of interest are modeled as latent factors in CFA. CFA helps evaluate the extent to which a set of measures accurately reflects the theoretical constructs they are intended to measure. The hypothetical construct are represented as unobservable variable or factor in the CFA model. The latent factor represents the underlying variables that cannot be directly measured but are inferred from the observed indicators. Why CFA? Observe measures, example questionnaire items, test scores, or often contains random errors or noise, we can say in SEM model, affects their reliability. These are common sources of observed data that may be contaminated by measurement error. Measurement error can lead to biased estimates when examining relationship between variables. Random errors in observed variables can cause an underestimation of the true correlation between constructs. Measurement error can also bias regression coefficients, leading to incorrect inferences about relationships. CFA aims to separate the true individual differences, true score variances, from the random noise or error variance in observed variables. Sorry for the inconvenience. I forgot to run the Probit model here. I'll again run the I'll run the Probit model here. Then we'll go back to CFA. So to run the Probit, we'll simply type Probit, and we'll take a dependent variable and independent variable. We hit the enter button, and we'll get the result. Okay. Then we can estimate the variables also, like estimate, first of all, estimate store Logit and estimate store Probit. We'll go to the data window. You can see here estimated Logit and estimated Probit is here. Now we'll run this command, estimate table Logit Probit B percentage of 9.3 F T variables. So we will get the difference of these results. Here we can see we are getting the same kind of results almost, in Logit and Probit. Okay. We can use the link test command to see the variability. We use the link test command to check the specification error. Now I'll go back to STATA to CFA model. In CFA, researchers must specify a hypothesized model with the number of factors and the pattern of factors loading based on theory or prior research. The hypothesized model specifies the number of latent factors or constructs. The model also specifies which observed variables are expected to load onto each latent factor. The CFA model describes the relationship between the latent factor and the observed variables. The unobservable constructs of interest
Sorry
are
for
represented
the
as latent factor in the model.
Hello.
Observed
Am I-
indicators or measures are hypothesized to reflect the underlying latent factors.
Am I audible
Estimates
to you,
here.
ma'am?
Yes, sir.
Am I audible to you?
So,
Yes. So we request you to kindly wind up the session in 3-4 minutes.
wind up. Sir,
To conclude the session in 2-3 minutes.
okay.
Because
Okay, sir.
our participants are getting.
Okay, sir. Okay, sir.
Thank you
Okay,
very much.
okay, sir. Fine. Okay, sir. We'll look at the path diagrams. Symbols. First, this is the oval shape is latent factors, and the rectangle shape is observed or manifest variable or indicator variable. The arrow is the directional relation path or factor loading, and the variance of the latent factor are represented by the double-sided arrow with the 2 points, right? And the double-sided arrow is the covariance or correlations. Residual error variance, terms of uniqueness, and constant of mean are the third one. So first, we have to identify the model. So there are 3 possible situations in model identifications. First is just identified model when degree of freedom is equal to 0. It refers here model identifications. Why we do? Because it is the important step in CFA or in SEM. It refers to the process of determining whether there is enough information in the data to derive a unique solution for the parameter or not. There should be only one unique. In the first case, when df is equal to 0, there is only one unique solution for the parameters, and the model has 0 degrees of freedom. Just identified model are not scientifically interesting because they perfectly fit the data. And in the second case, that is over-identified model are desirable because they allow for statistical testing of the model fit and the significance of parameter estimates. Right. And in the third case, degree of freedom, there is not enough information in the data to obtain a unique solutions for the parameters that is under identified model and that have negative degrees of freedom and cannot be estimated or tested. Okay. So here we have formula for unique or can say non-redundant sources of informations, P into P plus 1 over 2, where P is the number of observed manifest variables to be modeled. For this one factor CFA model, which consists of 4 observed variables, 1, 2, 3, 4. 1 is the latent variable role clarity. And for role clarity, the manifest variable is item 1, 2, 3, and 4. Right. So the number of unique non-redundant sources of information is equal to 4 items. We have the 4 into 4 plus 1 by 2, that is 10. So number of unique sources of information if we have to see. So here, the 1.0 value on the first factor loading in a CFA model serves 2 key purposes. Scaling the latent variable. It sets the metric units for the unobservable latent factor. Right. Second, aiding model identification. Fixing the first loading at 1 provides a reference point and reduce the model's degrees of freedom. Right. And typically the first factor loading or one that we specify is constant at 1. Here, how we identify, as in you are trying to solve a puzzle, but you don't know how many pieces you have to, or how many pieces you need to complete the puzzle. That's where counting the free parameters comes in. In our puzzle analogy, the free parameters are like the loose puzzle pieces that we can move around and estimate. The constant factors loading to 1.0 is like a puzzle piece that's already fixed in one place. It's not a free piece that we can estimate. So to figure out how many free pieces, free parameters we have, we start by counting everything else that's not constrained or fixed. First, we have the variance of our latent factors, the overall picture we are trying to build. That's one free parameters. Then we have the factors loading for the other observed variables, item 2, 3, 4. Those are three more free parameters. Finally, we have the distribution terms, or can say residual error variance for each observed variables. Those are another four free parameters. So adding all those up, we have 8 free parameters that we can estimate in our model. Now we compare that to the total number of unique pieces of information we have, which is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? 10th one is variance. Since the number of free parameters is 8, is less than the total pieces of information, that is 10, our degrees of freedom are positive. This means our model is over-identified, which is good thing. And an over-identified model means we have enough information to estimate all the free parameters and still have some wiggle room to evaluate how well our solution fits the data. So by counting the free parameters and comparing them to the total informations, we can determine if our model is solvable and testable, which is crucial for getting reliable results and evaluating our solution fit. Model fit indices. When a model is oversimplified, identified, degree of freedom is greater than 0. This means the model has positive degrees of freedom, indicating there is enough information to estimate model. And we can assess model fit, chi-square, a statistical test that evaluates the overall model fit. A non-significant chi-square value indicates good model fit. Chi-square test, the actual chi-square statistics that test the null hypothesis of perfect model fit. Comparative fit index, that is compares the fit of the target model to a baseline independent model. And the value should be greater than 0.9 or 0.95, indicates good fit. Tucker-Lewis index, similar to CFI, but includes a penalty for model complexity. Its value should be greater than 0.9 or 0.95, suggests good fit. Root mean square error of approximation, that we call it as RMSEA, measures approximate fit fit in the population values. And the value should be between less than 0.08 and 0.06, indicates reasonably fit. Standardized root mean square residuals represents the average residual value from fitting the model. Value should be less than 0.08, are deemed acceptable. So in summary, we can say that when a CFA model is over-identified, various fit indices can be examined to assess how well the hypothesized model fits the sample data. These include chi-square test as well as incremental and absolute fit indices. So let's take one example. I will conclude after this example. The example is based on a presentation by Byrne from her book on structural equation modeling. The focus is on performing confirmatory factor analysis, CFA. The data comes from the Mashlas-Bernard inventory, which assesses emotional exhaustion, depersonalization, and personal accomplishment. Subset of items. Instead of using all inventory items, we will work with a smaller subsets. The goal is to demonstrate analysis using STATA. Okay. So here, first of all, the result window as I want to discuss the things. Here, the model components we have, the diagram, this include boxes, arrows, and ovals, right? Ovals represents latent variable, not directly observed in the data. Boxes represents manifest variables or indicator variable of latent variable. Error terms, each box's indicator variable has an associated error term, that is E1, E2, E3, E4, and so on. These error terms accounts for variation in the observed indicators. Double-headed arrows indicates correlations between variables, like E3 correlates with depersonalization exhaustion, emotional exhaustion correlates with depersonalization, emotional exhaustion correlates with personal accomplishments, and so on. This model is drawn using the STATA diagrammer tool. We'll go back to the STATA window. We'll clear this data, clear all, and control off, control O. We has shared the data. Please please upload this data in STATA file. So the data file has downloaded. We'll go and check the data editor. We have here EE1, E2, E3, E4, and so on variables on emotional exhaustions, PA1, 2, 3, 4 on personal accomplishment, and DP1, 2, 3, 4 for depersonalization variable. So we have all these variables and the information is here. So what we will do here, we'll go to statistic and then SEM structural equation modeling, and we select model building and estimation. Once we select model building estimations, a canvas will get open. We will resize the canvas. I'm making it 100 and resize the area that I'm keeping it as 8 into 8. And click on OK. You will be having more area to draw on. First of all, what we can see here to the left hand side, some icons are there. Okay, that we've discussed just now in the slides. Here, we will select the square one. That means that when I am keeping my cursor on this icon, it's showing that add observable variables. We'll click on that and we'll make one E1, one manifest variable for E1, and then E2, then E3, E4, and then DEP1, DEP2, DEP3, and DEP4. Again, personal accomplishment 1, 2, 3. I'm reducing the size because my canvas is not supporting. One more, right? So we have all the 12 selected. So we will name them. We'll click on this rectangle. We'll name them. That first one is EE1. Second one, we click on the second one and we select the EE2 in the variable name. Third rectangle we'll select and the variable name will pop up. Here we can select the EE3 variable. Now here we'll select the EE4 variable. Next we'll select depersonalization, DEP1. Then DEP2. DEP3. And DEP4. Now the next last one, personal accomplishment PA1, second PA2, third PA3, and the fourth one PA4, right? So we have named all those. Now we will click on the oval shapes. It will showing that add latent variable. Clicking one for all these 4 emotional exhaustions variable, manifest variable, second for depersonalization variable, and the third for personal accomplishment variable. So all these 3 latent variables, we have to name them. The first one, we click on the oval shape, the first one, name the variable, we'll type emotional and press enter. Next, depersonalization, DEPERS, press enter. We'll click on the second one. The third one, personal accomplishment, ACCOMP, and press enter. We'll name the third latent variable. Now the next one is using the directional path to connect the latent variable to manifest variable. Right? One is done. The second, connecting latent variable depreciation to DP1, depersonalization to depersonalization, manifest variable DP1, 2, then 3, and then 4. My dear participants, I cannot stop in between. Just please. Now all these things are done. So what we have to do next is we have to fix the first factor, right? Factor loading can say. So we'll click on the first factor and we'll put 1, enter. This is fixed now. Second, in the second case, 1, enter. And in the third case, 1, enter. Now we have constructed the SCFA model. The next task we have is we have to show the covariance between emotional and depersonalization. So we will use this double arrow line. So we will make emotional exhaustion and depersonalization. So it shows the covariance between emotional exhaustion and depersonalization. Again, we'll draw from emotional depersonalization and personal accomplishment. And the third one, covariance between emotional exhaustion and accomplishment, right? And another E3 to E3 depersonalization. Right. Now all things are done. Now we can estimate the model. Estimate. A pop-up window will appear. Here we have 3 options: maximum likelihood with missing values, and asymptotic distribution free. So I don't have any missing value in my data, so I'll go with maximum likelihood. I'll click on OK. And we can see that our model is estimated. If we are clicking on this variable, this covariance with here on the right hand side, we can see the detailed result. Okay. See here, covariance between emotional and depersonalization have a positive relationship. Depersonalization and accomplishment have negative correlation, and emotional exhaustion and accomplishment has also negative correlation. Here it's showing, right? So this is the result, and we can run CFA on STATA like this only. I have to discuss a lot about CFA and how we can read the factor loading and error term variance, latent factor variance, covariances, and other things, chi-square, goodness of fit, and other things. But time is lagging, so I'll wind up the session.
So
Okay.
you can share this, well, we will, request you to share this in our PPT so
Sorry,
that
sir?
we can be. So we request you to share this, PowerPoint so that we can share it with our
Sure, sir,
participants.
sure.
Whatever is, whatever we were not able to discuss, they can, try to
Sure.
follow up. So over to you, Professor Richa.
Yes, it was a nice session. Again, time constraint is there. That's why we could not cover all the things. I got 2, 3 questions in chat box. The first question is, If we have more than one independent variable, do the units of measurement be same for all? Like one can be in dollar and other can be in percentage. Is it possible?
No, we have to convert. One can be in dollar and one can be in percentage. In
Percentage.
case of
Yes.
LPM or Logit or Probit, in which case you're talking about, no?
I think they are talking about Logit Probit probably, because in this we cannot have different units.
Ma'am, so sorry. We will show in the percentage form only. I mean, transform the variables into percentage form and then we run the logit regression model.
Okay. And is it mandatory that while explaining the results, do we simply explain 1% increase in independent variable increases or decreases the dependent variable by this amount? Is it mandatory to write like this or explain like this?
No, we can show in decimal form also 0.159 and also it's we use percentage form because here we are looking at the outcome as a probability. So
Okay.
that's why we use percentage form.
Okay. So again, the second question is regarding degree of freedom.
Right.
Madam Jaskiran is saying, though I know the theoretical meaning of it, but what
Uh-huh.
is the practical implication of it, and why is it mandatory to inculcate that in certain situation?
We have to look at degrees of freedom because it is important. If we overlap these degrees of freedom, we may get results that will be biased or not consistent. So the other factors is important, but degrees of freedom we have to look into.
Okay, one more question is like the model building we can do in Amos, the model building we can do in PLS SEM. So
Yes.
how it is better than the other
Yes.
softwares?
No, every software has its advantages. I am comfortable in Stata. That's why I
Okay.
use Stata. We can run the same thing on Amos on the PLS. No problem in learning and using
Moreover,
another
what
So,
software.
I think is PLS and these are paid softwares, isn't it?
No. Yes, ma'am. But I am comfortable because I am used to work
No,
on
it is
Stata.
not
That's
about
why.
you. I'm in general saying this thing. These softwares are the cost is too high.
Okay.
so
Probably
can
yes.
you set off the screen and ask the participants to open their camera
Yeah,
and
sure, sir.
while taking questions?
Is any other
So yeah,
question from participant side? Any other
there is
question?
Muhammad Ali is there. His hand is up.
Yeah.
Okay, yes, yes.
Am I audible?
Yes,
Yes, yes.
Mr. Ali.
Okay. Thank you very much for a very insightful talk. You have basically touched upon it, but for my naive understanding, given the Logit and Probit example that you gave of loan approval, which model would you use, Probit or Logit? If you could tell us why, from a practical perspective, that will be very useful. Thank you so much.
Sir, it's all on theoretical. The data that whatever the data you have based on the data, which model suits, we see based on the data and the theory that we have. I mean, I'm not so uh, uh, well versed on which data should we use on Probit and which data should we use on Logit. But in my uh, PhD, I use Probit model. I heard from others that they use Logit model. I had to run the regression on migration, right? Whether to choose migration, whether to migrate in cities or not, something like that I used. So in that case, I used Probit and I got good results. So it was a, like we can say that it was a primary data survey, primary data method. And I used Probit model. And in which case Logit is used. I haven't done study till now on Logit model. I'm comfortable on Probit, but whatever study I've done is based on Probit. So I'll get back to you. I need to study about it. Thank you.
Any other question? Okay, I think
So
yes.
can you set off the sharing so that we can bring all the participants on the
Right.
screen?
Ma'am Meenakshi, please stop screen share.
Oh, so sorry.
It's okay. It's okay. How to download Stata? One more question.
That we can't. Actually, we have the softwares I have got from my university, that is licensed version. So we have to buy or we have to get it from our institution.
Okay. Okay.
We have to pay
There
it
are
now to get the
some
software.
pirated version are there, but it takes time. You need, some expert. So I
Yeah.
suggest to you, visit some good institutions where you can get from the student and the lab. So
Okay. It
yeah,
was
it
a
is
nice
fair totally.
it was a nice session from Dr. Meenakshi, and I think participants are benefited from the session. Uh, there is no more question that make a sense that things were clear. So now I hand over to Dr. Firdaus for concluding remarks.
So thank you very much. So I appreciate participants for their patience today because due to some technical reasons, we got delayed. And but both the sessions were, quite important to learn the basics of the data software. Now the second session we have tried to explore some, model based, trainings. But in upcoming sessions we are going to have more advanced sessions. So be, enthusiastic and try to join on time and follow the discipline, just mute and all. So let me, formally give my vote of thanks to all the, resource persons, Professor Sanatan Nayak, who taught us today basics of data and some basic commands, binary and multivariate, this commands and tools and techniques how to do it. But as it is one of the limitations of online research methodology program, we cannot cover all the things at once, and due to some technical errors and all, we are just getting brief insights. Rest all of you have to practice yourself. You have got inputs that how to do and how not to do. But rest it is up to the research scholar or researcher or professors or newcomers. They have to engage themselves to learn these things. So it was quite insightful from Professor Sanatan Nayak and the moderator that in the first session, Dr. Ikta. They have given us their fruitful time. Now in the second session we have really have great experiences and learn the modeling. I have also run Logit model during my PhD, and STATA software is a software which allows you to work you
Excuse
know
me, sir.
yes please.
Can you give us insight that what is the difference between Logit and Probit? I mean, why we should use Logit and why in which like sir questions sir Mr. Ali sir
Yes,
that in which
actually Mr. Ali sir is I think he's an expert in data and this data modeling. So that is
this question
why
is only in my mind. Once I get I get the answer, then only I will get satisfied.
no, actually
That's
every
why I'm asking.
yeah I can give as of now I have not used this Probit and Tobit model, but I have used this binary logic regression. But as per my understanding, it's the general understanding. I cannot know the technical reasons. But every model is having it is assumptions that if those assumptions are failing, I have heard about these all three models. They are quite similar in nature. Whether it is a logit or it is a stop it or it is a what is the another one?
So Tobit is a bit
Probit,
different.
probit,
Probit and Logit
and
as well.
yeah, there is slight differences. But what I have heard that if the assumptions are not going in line with the data, then you can shift to other. And there is some element of this you know observations that in Logit you can you can go with certain limited observations, but in Probit and Tobit you can go both. And but let us open the mic for Muhammad Ali. He can give us some insights on it because I know he is the expert and he is the pass out from Germany, one of the great institutions, and he is working on big data. So I would love to request sir to give some input about it. Sir, over to you. Just kindly, give some insights about it.
No, sir, it was not a gotcha question. It was a genuine question.
Yeah.
Yes, yes.
Because the reason was because I also worked at the World Bank, and I was really surprised to find out that they did not care about Logit and Probit at all. They directly go to LPM. And as Madam also very rightly pointed out, there are several weaknesses of LPM. But in practice, when policies are really at hand, they use LPM for some reason. So this is why I am so the only thing that we have learned during our studies in Germany is that they calculate both Logit and Probit, and then they compare Akaiki information criteria, and then they see which one is more fit, better fit or not. But the underlying assumption is the distribution of the latent variable at hand, which is not so easy to actually compare when you're actually trying to apply Logit or Probit together in at the for the problem at hand. So it's not a very easy question to answer, and it was a genuine question. I'm still looking for a reasonable answer for it.
Why I have chosen Probit model, because it's based on standardized normal value. That's why. And interpretation of logic ratio is a bit difficult. So I chosen Probit simply based on the theoretical part. When I studied Woolridge, I found that Probit is a better model than Logit, so I have chosen simply. So this is the thing.
Okay, so if we are having any more questions, so that I will, continue my
Yes,
word
sir.
of
So sorry to disturb you. And
no issue. So it is quite interesting when, participants are getting, active and they are making the session more interactive. So it really, gives a edge that we are doing something good. So as of now, there is no question. So let me, give a vote of thanks for the last session. As we have discussed that there are certain questions which are unanswered. So it is again the homework for the participants and all of us to know the difference between Logit, Probit, and and Tobit. So it was a great learning from Dr. Meenakshi, and I am very thankful at a very short notice she has accepted our call to give to deliver a lecture in this research methodology on behalf of Jammu and Kashmir Economic Association, as this is our host program. So I would like to thank Dr. Meenakshi and our moderator Richa Banerjee, which has been replaced. She has replaced her husband because of some reasons, and she has joined us at a very short notice. So overall, I am sorry for the participants because we have delayed the session and we are quite late. But on the other side, I'm quite happy that some incredible things has happened as Professor Richa Banerjee has replaced her husband and she came all together and to present the session. Thank you very much once again. So it was our fourth day, and with great energy, great patience, and great learnings all together, we have started today's STATA. Tomorrow we are having more technical sessions and more advanced we are going to learn tomorrow. So be on time, and one research person has given some information. Please join before 15 minutes. He will teach us about the Grittle model, this Grittle software, how to install. He will help us all how to install it, and on the time later on we will start the session. So once again, thank you very much. If you are able to open your camera, we can take some group photos. If not, then we can.
Let me thank you, sir, because promises was made, so promises should be kept. That's why, because of unhealthy condition of my husband, I had to keep his promise. So thank you for accepting that change.
So I appreciate it because you have done it. Sometimes it is it is not easy to handle at the final hour to take the responsibility of someone. So, but yes, it is a great learning that online we can do it, but offline it is quite impossible. There are limitations both in online and offline. But yes. So thank you very much, all the participants. We are going to update you on WhatsApp, and today's feedback link we are going to share on WhatsApp again. So be remain connected and try to respond all the the chat which we are sharing on WhatsApp, because it is very important. So we are maintaining right now, we are maintaining 80% of attendance of yours. So if you give 80% of attendance, then you will get other benefits, recording and all. So the motivation is only that you will learn from this, because there is great effort behind this workshop. It's not easy job. I am managing it all together with my friend, but I request you all to learn and take advantage of it. So with these words, I am once again thankful to all of you. You can now leave this session because we are having the same link for all the 9 days. If you not leave, so it will remain like this. So you all have to leave the session now so that we can leave. We have not to close the session. Thank you very much. And you will get your photographs and all on our LinkedIn page and Facebook page. So remain there connected and follow the page. So all participants, we are having 35 participants, some are offline. Unless and until you leave the session, we cannot do